Let's express this given permutation as a product of transpositions. Now, transpositions are actually cycles of length 2. Now, we can determine the cycles that we will be using here if we are going to look into the idea of expressing this permutation first as a product of disjoint cycles. And we already done that in our we have done that already in our previous video. You might want to check that previous video. And I'm just going to copy here the result. We actually have the result for this. This permutation can be expressed as a product of these 3 different disjoint cycles. We have 1, 3, 4. And you have here 2, 6, and then 5, 8, and 7. If you are not sure with this, you might want to review that specific video in your own time. Now, take note that we were able to determine that this permutation is not a cycle, but we were able to come up with 3 different disjoint cycles that resulted to this permutation when multiplied, and verified that again in the previous video. Now, these 3 cycles here are actually to be used in determining the expression of this permutation as a product of transpositions, because as mentioned earlier, transposition is a cycle of length 2. We're already talking about that on our second cycle here, 2, 6. This is already a transposition because it has 2 elements here alone. Still, it has 8 elements in S8 because it's a part of S8, but 2 is mapped to 6 here, and 6 is mapped to 2, but the rest of the elements, 1, 3, 4, 5, 7, and 8, are mapped to themselves. That's also the case for 5, 8, 7 here. All the rest of the elements are mapped to themselves. So this is already a transposition. What we need to do here is to express the other 2 cycles. You have 1, 3, and 4. And we have here 5, 8, and 7 as a product of transpositions as well. Then, if we're done with that, we can express the entire permutation here as a product of transpositions resulting from all of these processes. This is how we write transposition. Say, for example, in 1, 3, and 4, this is actually the first element here. We are expecting a product of transpositions, meaning product of cycles of length 2. So we have here in this form, or more, right? Or more. But we can have 2 here as we are writing transposition in this manner. We will copy the first element of this cycle, 1, and place 1 here. Then that 1 will be paired to the farthest element, 4. So we have here 1 and 4, and then we move from right to left. The next is a 3 that's placed here. Okay? So again, we copy 1. That's 1 and 1 here. Then the farthest is 4. Then from right to left, the next is 3. If you're not convinced with this, you could always try multiplying this. Okay? Or you could try actually looking for the mapping of that. Let's just not include 2, 5, 6, 7, 8, because for this cycle, as mentioned, the other elements are mapped to themselves. Let's just simply look into the mapping of 1, 4, and 3. So let's start with 1. 1 is mapped to 3. 3 is mapped to 3. This is correct. 1 is mapped to 3. Right? Let's have 3. 3 is mapped to 1. But 1 is mapped to 4. That would mean 3 is really mapped to 4. That's correct. And finally for 4, 4 is mapped to 4. 4 is mapped to 1, same as this. So these 2 transpositions in this exact order results to 1, 3, and 4, the cycle 1, 3, and 4 when multiplied. Let's duplicate the same process for 5, 8, and 7 because we also have 3 elements here. So we are expecting to have 2 transpositions. Copy the first element, 5 here, and the farthest is placed here, then right to left here. So these are the 2 transpositions that will result to 5 and 8. Again, no need to worry about 1, 2, 3, 4, and 6 here. Let's just focus on 5, 7, and 8. Let's have 5. 5 is mapped to 8. 8 is mapped to 8. Hence, 5 is mapped to 8. That's correct. For 7, let's have 8 because 8 is the second element here. 8 is mapped to 5. And 5 is mapped to 7. Hence, 8 is mapped to 7. That's correct. For 7, 7 is mapped to 7, 7 is mapped to 5, that's here. So this is also correct for that. Now with these two cycles already expressed as a product of transpositions, we can combine them into this middlemost transposition here. That would mean our permutation here can be expressed in this product of transpositions. For 1, 3, 4, you have 1, 4, 1, 3. Then you have your 2, 6 here. Then for 5, 8, 7, 5, 7. Sorry, that's parenthesis. And 5, and then 8. So you have 5 transpositions. When multiplied, will result to our given permutation. Now, of course, if you're not convinced with that, you could always check. 1, 2, 3, 4, 5, 6. That's 6. Let me repeat that here. 6, 7, 8. If the product of these 5 transpositions will return to the given permutation, that is already correct. Let's start with 1. 1 is mapped to 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 3. 3 is mapped to 3. Next, 2. 2 is mapped to 2. 2 is mapped to 2. 2 is mapped to 6. Now we are at 6. 6 is mapped to 6. 6 is mapped to 6. How about the 3? 3 is mapped to 3. 3 is mapped to 3. 3 is mapped to 3. 3 is mapped to 1. But 1 is mapped to 4. Okay. How about 4? 4 is mapped to 4. 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 4 is mapped to 1. For 5, 5 is mapped to 8. But we are now at 8. 8 is mapped to 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 8. 6. 6 is mapped to 6. 6 is mapped to 6. 6 is mapped to 2. We are now at 2. 2 is mapped to 2. 2 is mapped to 2. Next, 7. 7 is mapped to 7. 7 is mapped to 5. 5 is mapped to 5. 5 is mapped to 5. 5 is mapped to 5. And finally, for 8, 8 is mapped to 5. But here, 5 is mapped to 7. So we are now at 7. 7 is mapped to 7. 7 is mapped to 7. 7 is mapped to 7. Is this the same as the earlier given permutation? 3, 6, 4, 1, 8, 2, 5, and 7. It's correct. Therefore, again, rewriting all of this. 1, 4, 1, 3, 2, 6, 5, 7, 5, 8. Sorry for that. 5 and 8. Okay. With all these 5 transpositions, this will return to a given permutation, and this is the answer to this given concern. Thank you very much for watching.